When the James Webb Space Telescope first opened its golden eyes, the universe seemed to hold its breath. Out there, beyond the pull of our planet, a vast machine unfolded in silence, petal by petal, like a flower blooming in the dark. Its mirrors caught the first light of distant stars, light that had wandered for billions of years through emptiness, across oceans of time. When that light touched the mirrors, something extraordinary happened. The telescope didn't just look into space, it looked into time and saw the ghosts of creation staring back. For most of human history, the night sky was a mystery that refused to answer. Ancient people looked up and saw patterns, gods, stories written in starlight. Centuries later, Galileo turned a small telescope toward Jupiter and found moons circling worlds. Hubble showed us galaxies, billions of them, drifting through the void. Yet even then, our vision ended in a faint misty glow, the edge of what we could see, the cosmic horizon. Beyond that was only imagination. Then came Webb, humanity's most delicate eye, built not to replace Hubble, but to finish its sentence. Before Webb, our gaze into the past was like peering through fog at a city of lights, blurry and incomplete. Hubble saw the afterglow of ancient stars, but not their birth. It gave us a universe already in motion, already old. The question of how it all began, how darkness learned to shine, remained out of reach. Webb was built to see deeper, to reach that hidden dawn when the first galaxies were young. Its mission was both simple and impossible, to see the moment creation first took shape. In 2021, after decades of planning, the telescope left Earth, carried by a single, trembling rocket flame. For 29 days, it traveled away from us, toward a silent point in space called L2, 1 million miles from home. There it unfolded with careful grace, layer by layer, as though performing a slow, sacred ritual. First, the sun shield spread out, thin as silk, protecting it from the heat of the sun. Then came the mirrors, gleaming gold, each hexagon polished so perfectly that if it were the size of a continent, its surface would have no mountain taller than a single hair. Those mirrors caught the faintest whispers of light, rays that began their journey before Earth existed, before the Milky Way had formed, before there were atoms in your body or breath in your lungs. Light older than life itself. Every photon that entered Webb's detectors carried a memory, a message written across 13 billion years. To see such light was to open a window not just into history, but into time itself. From its distant perch, Webb drifted in eternal balance, held in place by the gentle tug of gravity from both Earth and the Sun. It does not orbit our planet, but dances with it, circling the Sun in step, always facing the deep. Out there in the cold, it is quiet, the kind of quiet that has no echo. Only the steady hum of instruments, the faint murmur of a machine listening to the oldest voices in existence. When the first images arrived, scientists held their breath. What they saw was unlike anything expected. Galaxies appeared too bright, too heavy, too mature for their age. They were supposed to be infants, chaotic clouds of gas still learning to form stars. Instead, they looked ancient, majestic spirals and clusters that should not exist so soon after the beginning. The universe, it seemed, had broken its own rules. For a moment, confusion spread through the scientific world. Had our models been wrong all along? Were the equations we trusted just stories we told ourselves to make sense of the dark? The galaxies Webb revealed were like fossils that shouldn't belong to the era they were found in. A history that had unfolded faster than it should have. The telescope had shown us something deeper than distance. It had shown us contradiction. The beauty of those first images was undeniable. Glowing nebula shaped like wings, threads of light crossing space like veins of gold. Yet behind the beauty was unease. The cosmos had always felt vast, but now it felt alive, shifting, unpredictable, almost aware of being watched. In every glowing swirl of dust, in every fragile spiral, there was the echo of something long gone yet strangely familiar. It was as though the universe had left behind a gallery of its early memories, waiting for someone to finally notice. To look at those images was to feel a strange mixture of wonder and humility. Somewhere inside, the human mind reached out across the gulf, whispering to its own origins. The same atoms that made the telescope's mirrors once burned in forgotten stars. The same light that brushed across distant galaxies now touched our retinas. The line between observer and observed began to blur. The telescope was not just looking out, it was looking back, through us, through everything that ever was. For those who worked on Webb, the moment was deeply personal. Years of calculations, failures, restarts, frozen fingers in clean rooms, endless nights staring at screens, all leading to a single image, a speckled pattern of red and gold on a black canvas. To most, it was just light. To them, it was time itself, unspooled and caught by a mirror the size of a house, floating in silence. That mirror, burnished gold, became a symbol of something larger than science. It represented the desire to see further than we are meant to stretch perception until it bends. It showed that even in the coldest corners of reality, beauty hides, waiting for eyes brave enough to open. But beauty can be unsettling. In those first weeks, the world saw galaxies that seemed too eager to exist, as though the universe had hurried its own birth. The story of creation, once neat and orderly, began to fracture. The early universe was not gentle or gradual. It was wild, explosive, impatient. Perhaps it still is. Take a breath. Picture that telescope now, still floating in its quiet orbit, mirrors glinting against the black. Every second it gathers more light, more memories, more fragments of time. Somewhere in that data, hidden in a pattern of pixels, lies the story of how everything began. To understand what Webb truly revealed, we must go deeper. We must ask what it means to see something that no longer exists, to gaze into the past so far that time itself begins to look back. Every star you have ever looked at is already a memory. Its light has been traveling for so long that by the time it reaches you, what you see is no longer what is. The shimmer that flickers above the trees, the soft white glow that you called a wish upon, all of it began its journey across time long before your eyes ever opened to the night. Some of those stars are still burning, steady and alive. Some have already collapsed, their fire long gone. What remains is their ghost light, a message written in brightness, sent across the dark to remind you that nothing truly vanishes without leaving a trace. Light is patient in a way nothing else is. It moves at one speed only, fast enough to cross the universe, but slow enough to tell a story. About 300,000 kilometers each second, no faster, no slower. It carries with it a record of every moment it passes through, stretched and changed but never erased. The night sky is filled with these records, a collection of moments frozen in motion. Each star becomes an entry in a cosmic diary that never stops writing itself. When you look up, you are reading history written in photons. That's what makes stargazing such an intimate act. It isn't about distance, it's about time. The light from Sirius, bright and white in winter, began its trip 8 years ago. The glow of Betelgeuse started more than 6 centuries earlier. Before telescopes, before cities, before electricity. Some of the faintest stars you can see with your naked eye began shining when our species was still learning to speak. You stand on a small planet, looking into the past, surrounded by light that remembers what you cannot. In the silence of space, light becomes the only witness. It watches galaxies form, watches them collide and drift apart, watches stars live out their brief, burning lives. Then it carries their stories forward, endlessly. The photons that touch Webb's golden mirrors today were born before the Earth took shape. They passed by clouds of gas, through clusters of stars, through dust, through nothingness. Each one a survivor of impossible journeys, arriving at a machine built by creatures who just recently learned to wonder. There is something deeply moving about that. To realize that the light Webb captures is ancient beyond comprehension, yet still alive enough to reach us. The telescope doesn't just take pictures, it receives messages. Some are sharp and clear, others faint, nearly lost to time. But every one of them is a ghost, the echo of a star's final breath, preserved in motion. When Webb collects those photons, it is like catching whispers that have been traveling for eternity. The universe, then, becomes a place haunted by its own history. Not haunted in the fearful sense, but haunted like an old house filled with stories. Every room, every corridor carries traces of what once happened there. The light we see is the echo of those moments. Even darkness holds the memory of something that once shone. Sometimes late at night, it feels almost personal. You step outside, the air cool, the world quiet. Above you, countless points of light shimmer. You are looking at a sky filled with ghosts. They don't frighten you, they comfort you. Their glow is proof that something once existed, burned bright, then faded. Yet its presence lingers. In their persistence lies a strange kind of tenderness, as though the universe is unwilling to forget itself. Light has no mass, yet it carries weight. It bends under gravity. It stretches as space expands. It can be trapped, bent, magnified. Sometimes, entire galaxies act as lenses, bending the light from others far behind them. What Webb sees in those arcs and distortions is more than beauty. It's time, warped and sculpted. A single image can hold 1,000 different ages layered on top of one another, all speaking at once. To look at those images is to confront the reality that nothing in the universe is truly still. Everything is moving, changing, leaving trails of light behind it. Even the stars that appear fixed above you are racing through space at incredible speed. Their light is the only thing that remains constant enough to give the illusion of permanence. Yet even that illusion breaks under Webb's gaze. The deeper it looks, the older the ghosts become, until time itself seems to dissolve. The galaxy's Webb photographs are not as they are, but as they were. Some of them have changed beyond recognition. Some may have disappeared entirely. The telescope shows us a universe that no longer exists, preserved only in light. That realization can be dizzying. The image on your screen is not a snapshot of now, but of then. A portrait drawn by something that left its subject billions of years ago. To see it is to see a memory so old it has forgotten who it belongs to. Yet that's the wonder of it. The night sky becomes a museum, each star a relic glowing faintly behind a pane of distance. You cannot touch it, cannot visit it, only observe the traces it left behind. The deeper the telescope peers, the more ancient the exhibits become. It reaches back through layers of time, peeling them away until only the first flickers remain, the faintest embers of creation. Those are the oldest ghosts, their light stretched into long red sighs by the expansion of space. To our eyes, they are barely visible, but to Webb, they are bright enough to tell their story. There's a quiet lesson hidden there. Everything leaves light behind. Stars do, galaxies do, so do we, in smaller ways. The light from your window spills into the night, joins the flow, drifts outward forever. Somewhere far in the future, someone or something might detect that faint glow and know that a human once lived here, once looked up at the sky and wondered. In that sense, you too become a ghost of creation, your presence written in the same language as the stars. The universe does not erase easily. It records, it remembers. Every photon Webb captures, every flicker that touches our retinas is proof of that. To look into the dark is to see not emptiness, but memory made visible. Take a moment to picture that light, ancient and fragile, still crossing space even now, each wave carrying the imprint of a star's last breath. The telescope waits quietly, mirrors glinting, sensors humming, collecting the ghosts that fill the void. Somewhere among them are the first lights ever born, still moving toward us. What, then, are these ghosts made of? What substance allows them to linger for so long, to outlast their own creation? To find out, we have to travel deeper, to the moment when darkness itself first began to glow. There was a time when the universe had no light, no stars, no suns, no colors. Only a vast, endless darkness stretching in every direction. In that silence, there were no shapes, no movement, only a thin, invisible fog made of hydrogen, the simplest and loneliest element in existence. The cosmos was like a blank page waiting for the first spark to write its name across it. Everything that would ever be, the stars, the galaxies, the planets, even you, was hidden in that quiet sea of nothingness, waiting to wake. In those early ages, space was dense, hot, and filled with potential. The heat from the Big Bang had faded just enough to allow atoms to form. They drifted together slowly, pulled by gravity's gentle whisper, gathering into invisible clumps. For millions upon millions of years, those clumps thickened, drawing in more gas, tightening their hold. The universe, though silent, was restless, like a breath being held too long. Then, in one of those clouds, deep in the ancient dark, something changed. The pressure grew so strong that the atoms inside fused together. In that instant, darkness learned to shine. The first stars were nothing like the ones we know. They were giants, hundreds of times more massive than our sun, burning hotter, brighter, faster. They lived violently and briefly, blazing through the blackness, with a light fierce enough to reshape everything around them. Their radiation tore through the hydrogen fog, clearing pockets of transparency in the once opaque universe. It was as though the cosmos had opened its eyes for the first time and seen its own reflection. Astronomers call this age the cosmic dawn, the moment when night was broken by starlight. But it was not a peaceful sunrise. It was an awakening marked by chaos and creation interwoven, stars igniting, collapsing, and exploding, scattering their ashes across space. From those ashes came the seeds of new stars, smaller ones, steadier ones, capable of living longer. Out of that turmoil, galaxies began to form, faint clusters of light gathering like dew in the dark. 13 billion years later, that first starlight is still traveling, stretched thin by the expansion of space. Its wavelengths have lengthened, shifted into infrared, invisible to human eyes. Yet that is exactly the kind of light Webb was built to see. Its instruments are tuned to the colors of ancient memory, to the faintest traces of warmth left behind by the universe's first fires. Every image it captures is a translation of that hidden language, turning cold, silent data into something almost poetic, a glimpse of when existence first began to glow. To detect light that old is to reach across nearly the entire age of the universe. Each photon Webb catches from the cosmic dawn began its journey before Earth formed, before even the Milky Way spiraled into shape. It has crossed space that has been stretching all the while, a traveler that has grown weary and red with distance. When that photon finally meets Webb's mirror, it completes a journey longer than time as we experience it. The telescope becomes a kind of time machine, holding the light of beginnings in the palm of its sensors. Seeing those first stars is like reading the opening sentence of existence. Every flicker tells us something about how creation started to write itself. But what Webb found in its earliest images complicated the story. The galaxies it saw at the edge of the visible universe were not the fragile, shapeless clusters scientists expected. They were mature, structured, glowing with surprising brightness. By all logic, they shouldn't have existed yet. The timeline of cosmic growth appeared too short to allow such complexity. It was as though the universe had skipped ahead in its own book, leaving out the pages that explained how it got there. That discovery stirred both excitement and unease. It hinted that our understanding of the early universe might be incomplete, that the forces shaping it were faster or more mysterious than we believed. For decades, the story had seemed simple: darkness, then stars, then galaxies, then us. But Webb's images painted a picture that was more intricate, less patient, filled with surprises. The first light was not a slow dawn, it was an eruption. There's something poetic in imagining that the universe began not with calm order, but with urgency. That creation rushed forward, spilling over itself, eager to exist. The light we see now is the echo of that impatience. It reminds us that even in vast silence, there was once movement, pressure, desire. The cosmos was not content to stay still. It wanted to become. When those first stars exploded, they scattered the elements that would one day form planets and life. Their ashes became dust, drifting through the void, fusing again into new generations of stars. Each explosion was both an ending and a beginning, both destruction and creation bound together. From death came carbon, oxygen, iron, the ingredients of everything familiar. The stars died so that the universe could diversify, so that light could find new shapes to inhabit. In the faint glow of the cosmic dawn, Webb sees not only the birth of light, but the cycle that still continues in every corner of the sky. Every star, every atom, carries within it the memory of that first brightness. When we study those ancient photons, we are studying our own ancestry at the most fundamental level. The same starlight that once carved open the darkness now reflects off oceans, shines through trees, glimmers in human eyes. The distance between the first dawn and now may be infinite, yet somehow the connection remains immediate, alive. There's a quiet sadness in realizing that we will never see those first stars directly. They lived fast, died young, and left behind no survivors. All that remains of them is their light, stretched thin and softened by time. Webb's images are not photographs of them as they are, but as they were, their glow a final gesture to anyone who might one day look back far enough. In a sense, the telescope is not just an observer. It is a listener, catching the fading hum of a universe that once roared with birth. When scientists look at the data, they are not simply studying numbers or wavelengths. They are decoding a song that began before there were ears to hear it. The notes of that song are faint, almost lost, yet still there, a record of the moment darkness first learned to shine. To study it is to study the transition from nothing to something, from silence to sound, from void to light. Sometimes late at night, it helps to step outside and feel that story in the air. The same darkness that once held the first stars now surrounds you. Somewhere beyond it, the light from those ancient suns is still on its way, though you may never see it. The night sky you know is only the most recent layer of the same unfolding story. You are living in its later pages, but the first lines still echo quietly in the background. The universe has always been telling a story, one written in brightness and loss, in cycles of collapse and renewal. Webb has given us the gift of reading the prologue, of glimpsing the spark that began everything. Yet in doing so, it has left us with an unsettling question, one that lingers long after the images fade. Had our cosmic history always been this incomplete? When the first images from Webb arrived, scientists expected beauty. They expected ancient light, faint smudges of the earliest galaxies, soft and small like whispers from a young universe. What they didn't expect was something impossible. The data showed galaxies that were far too massive, far too structured, far too luminous for their age. These weren't newborns. They looked mature, as if they'd lived through billions of years of cosmic evolution. Yet their light began its journey only a few 100 million years after the Big Bang, a time when the universe should have still been a child, just learning how to breathe. The discovery was like walking into a museum of prehistory and finding a fully built skyscraper standing among stone tools. By every rule of physics we thought we knew, it shouldn't be there. Galaxies, in our best models, start small. Tiny clouds of gas gather under gravity's pull, forming stars in clusters that gradually merge over eons. It's a slow dance, a patient choreography. The galaxies Webb found didn't follow that rhythm. They seemed to have skipped ahead, as though the universe had fast-forwarded through its own adolescence. Astronomers checked their instruments, recalibrated data, reanalyzed the distances. Maybe it was an illusion. Perhaps these galaxies weren't as old as they seemed. But no matter how they turned the numbers, the results stayed stubbornly the same. The light was ancient. The structures were real. The universe had built something grand before it should have known how. To understand the scale of this shock, imagine looking out into the night sky and seeing not faint pinpricks of light, but entire cities glowing in the darkness. Vast spirals, dense cores of starlight, all existing when space itself was barely 500 million years old. Those galaxies burned with an intensity that didn't fit any known rule. Their stars were too numerous, their shapes too organized. The cosmos, in its infancy, appeared to have accomplished what should have taken billions of years of patient construction. For scientists, this was not just an astronomical curiosity. It was a riddle that reached into the foundations of cosmic history. Our understanding of how the universe grows, how matter clumps, how stars ignite and form galaxies, all of it depends on time unfolding in a certain order. But these impossible galaxies suggested the order might be different. Perhaps the early universe was more efficient, more creative, more restless than we believed. Or perhaps our perception of time itself, stretched and warped across cosmic distances, is playing tricks on us. There's something unsettling about that idea, because time is the one thread we trust to make sense of everything. It tells us what came before and what comes after, what is ancient and what is new. Yet, in the light Webb captured, those distinctions blur. When we see a galaxy that should not yet exist, we are staring into a mystery of tempo, of how fast creation can move when left to its own devices. Some astronomers wondered whether the galaxies were simply brighter than expected, not larger. Maybe we were just seeing the most massive stars shining with fierce intensity. But even that explanation stretched belief. To shine so brightly, those galaxies would have needed to convert gas into stars at rates far beyond what physics allows. It's as if the universe, in its earliest breath, had found a shortcut to complexity. Others proposed that perhaps we were missing a piece of the puzzle, a hidden mechanism accelerating cosmic growth. Something unseen might be sculpting the large-scale structure of everything, guiding galaxies into being faster than light alone could explain. The thought was both thrilling and humbling, a reminder that our models are not laws, but stories we tell to make the vastness understandable. The images Webb sent back didn't just challenge science, they stirred emotion. There was awe in realizing how alive the universe was, even when it was barely awake. Those galaxies, glowing fiercely in the young dark, felt like cosmic defiance, a declaration that existence wastes no time. They seemed to say, "I am here, even before I should be." Each discovery brought new layers of wonder and confusion. The galaxies weren't just massive, they were organized. Some even showed spiral arms, the graceful curves of maturity. That shape was supposed to emerge only after countless collisions and billions of years of slow evolution. To see it in the first 500 million years was like finding an ancient drawing already painted in perfect detail before language even existed. For many scientists, this wasn't just a question of how, but of why. Why did the universe rush? What drove such speed, such urgency? Was it a sign that our picture of early physics is incomplete, that the forces shaping matter were different back then? Or could it be that something fundamental, something woven into the structure of space itself, is amplifying the growth of galaxies in ways we cannot yet see? The deeper the Webb telescope peers, the older the light becomes, and the more this mystery deepens. Each faint red smear captured in its mirror is like a fingerprint from the past, a signature written in photons. Yet instead of revealing clarity, these discoveries are complicating the story, showing us that creation might be more spontaneous than structured, more wild than predictable. It's strange to think that the universe might be better at making galaxies than our best equations suggest. That, in its earliest moments, when everything was chaos and heat, it already knew how to build beauty. Perhaps what we see as impossible is simply our limited sense of patience colliding with the universe's endless inventiveness. Still, the implications are profound. If these galaxies truly are as massive as they appear, then our understanding of matter itself may need rewriting. The rate of cosmic expansion, the timing of star formation, the role of gravity, all could be woven differently than we thought. It's as though Webb has lifted the corner of a grand cosmic tapestry, and beneath the threads, we glimpse patterns we didn't know were there. The discovery has sparked debate across the scientific world. Some argue that we've overestimated distances, that perhaps the light is tricking us through cosmic dust or lensing. Others believe this is exactly what it looks like, the universe breaking its own rules. The tension between these ideas isn't a failure of science, it's the heartbeat of it. Every new observation Webb makes is a conversation between what we think we know and what the cosmos quietly insists is true. There's a certain poetry in this confusion. For centuries, humans have tried to chart the order of existence, to map beginnings and endings, to make the universe logical. But the sky, it seems, doesn't always obey. Sometimes it tells stories out of sequence. Sometimes it builds cathedrals before foundations. Sometimes it shows us galaxies that should not exist, just to remind us that creation itself is still unfolding, still experimenting with what's possible. When you look at one of those Webb images, the tiny glowing arcs, the scattered points of light that are actually entire galaxies, it's hard not to feel small, but it's also hard not to feel connected. Those impossible galaxies are part of our lineage, our shared cosmic ancestry. Their impossible speed, their early brilliance, their defiance of time, all of it eventually led to us. The same laws that shaped them are still at work now, building and collapsing, giving and taking, forming new worlds as old ones fade. Perhaps that's why these discoveries move us so deeply. They're not just about distant light or abstract physics. They're about surprise, about realizing that the universe is still stranger than we dared hope. It reminds us that knowledge is never finished, that even with the most powerful telescope ever built, we are still children staring into the dark, trying to make sense of the stars. And so the question lingers, whispering beneath all the data and debate. Were our models of cosmic evolution wrong, or have we misunderstood time itself? To find the truth, we must look deeper, beyond what light can show us, into the invisible fabric that shapes it all, the mysterious substance called dark matter. In the quiet stillness between galaxies, something unseen holds everything together. It does not glow, it does not scatter light, it cannot be captured by any telescope. Yet without it, every galaxy ever formed would simply drift apart, dissolving into the void. Astronomers call it dark matter, a name that describes not what it is, but what it hides. For a long time, we didn't even know it existed. The universe looked complete enough, filled with stars, gas, dust, all the familiar ingredients of cosmic life. Then came the first signs of imbalance. Galaxies were spinning too fast. Their outer stars moved as if pulled by some invisible force, something far stronger than the visible mass could account for. There was missing gravity, an unseen weight pressing against the cosmic fabric. At first, the idea sounded absurd, a vast, invisible substance that outweighed everything we could see. But the evidence grew too heavy to ignore. The more astronomers measured, the clearer it became. Only a small fraction of the universe is made of ordinary matter. The rest, the overwhelming majority, is something else entirely. Something that does not shine, but binds. Dark matter became the universe's great ghost, present everywhere but visible nowhere. It surrounds galaxies in enormous halos, silent spheres of gravitational glue that hold the luminous parts together. It stretches between galaxies in vast webs, threads of unseen structure shaping the cosmic landscape. Every star, every cluster, every luminous thing you've ever seen hangs within this invisible architecture, like dew caught on the strands of a spider's web. When Webb turned its golden mirrors toward the earliest reaches of time, it wasn't only capturing starlight, it was mapping the consequences of that invisible structure. Every galaxy it saw, even the impossible ones, formed along the pathways dark matter had drawn. Without that unseen framework, the young universe would have remained a scattered mist of gas. But dark matter provided the scaffolding, the hidden skeleton upon which creation could take shape. The idea is almost haunting, that everything visible owes its existence to what cannot be seen. Those ancient galaxies Webb revealed might not be mistakes in our understanding, but signs of dark matter's quiet efficiency. Perhaps the reason the early universe looks so advanced is because dark matter was already at work, guiding the newborn cosmos like an invisible artist sketching the outlines before the colors are filled in. Some scientists describe dark matter as the universe's shadow, not a shadow that blocks light, but one that gives light its place to shine. It defines form through absence, presence through invisibility. The galaxies we see are not random islands floating in emptiness. They are settled within wells of gravity carved by this dark material. The earliest stars were likely born in its embrace, gas collapsing along the hidden filaments it shaped. Think of it as a kind of cosmic memory. Even before there were stars, before light had found its voice, dark matter was already arranging the stage. It was setting the rhythm, dictating where matter would collect and where it would not. The galaxies Webb observed, so bright, so mature, so early, might be echoes of that ancient choreography, dancing to a tune we cannot hear but whose rhythm still moves us. The beauty of this idea lies in its subtlety. Dark matter does not shout its presence, it whispers through gravity, bending space itself. The great arcs of light Webb captures, those delicate distortions of distant galaxies, are one of its fingerprints. They reveal where the invisible mass resides, that bending light's path like glass shaped by an unseen hand. Each curve, each warp, tells of the ghostly architecture beneath the visible sky. In that way, Webb is not just seeing stars, it's seeing the shadows of structure itself. The universe, through its distortions, is sketching the contours of its own hidden bones. It's as though we are watching the reflection of something vast that never directly meets our eyes, a silent partner in the making of everything we know. The thought is almost poetic. What we call dark is not evil, not absence, but the very condition for creation. Without it, galaxies could not have formed. Stars would not have gathered. There would be no planets, no life, no one to ask these questions. Darkness, it turns out, was the first artist. Somewhere in the deep silence of space, the gravitational pull of dark matter continues its patient work, sculpting, balancing, binding. Webb's images, brilliant, golden, full of color, are the visible face of that invisible labor. The luminous arcs and spirals are merely the skin stretched over a hidden skeleton of gravity. The true form of the universe exists in both, what shines and what does not. When scientists model the cosmos on their computers, they often begin not with stars or light, but with a simple equation describing how dark matter moves. They let it swirl and clump, forming filaments that intersect like rivers joining in a delta. Where those filaments meet, galaxies are born. It is there, in the crossroads of invisible gravity, that light finally finds a place to rest. This vision changes how we think about reality itself. What we see is only a fraction, a surface layer of a much deeper truth. The night sky, with all its brilliance, is like a reflection in still water, a faint shimmer of what lies beneath. Perhaps that's why the term ghosts of creation feels so fitting. The galaxy's web uncovers may not just be ancient light, they are also shadows of structure, shapes carved by something we cannot touch. There's a quiet humility in this realization. For all our instruments, our theories, our desire to grasp the cosmos, we are still mostly blind. We live in a universe where the dominant force is invisible, yet its fingerprints are everywhere. In the way galaxies rotate, in the way light bends, in the way the past still touches us through time. In a sense, dark matter is not separate from us. The same invisible framework that holds galaxies together also shaped the space where our own sun was born. Every atom in our bodies exists within its gravitational embrace. We are creatures of light, yes, but also of shadow. Both are woven into our origin story. Perhaps those impossible galaxies are not errors but revelations. Proof that creation's ghostly architecture is more intricate than we ever dreamed. That the cosmos doesn't need our permission to rewrite its own script. That what we see as contradiction is really harmony on a scale too vast for us to fully grasp. As the Webb telescope continues to stare deeper, it isn't just showing us the past. It's showing us how much of that past remains hidden. Every faint glimmer in its images is shaped by dark matter's hand. Every pattern in the deep field is a trace of its structure. The invisible gives meaning to the visible. The silence gives shape to the song. In the end, perhaps that's the real revelation, that darkness is not the enemy of light, but its companion. That creation begins not in brightness, but in shadow. That the universe itself may be a conversation between what shines and what hides. Take a moment to breathe that in, the quiet gravity that holds everything together, the unseen harmony beneath all things. Somewhere out there, in the places beyond sight, the shadows of the invisible are still at work, still shaping, still binding. But there is another mystery waiting in that darkness, one that began before galaxies, before stars, before even the first light found its way into the void. Before light found its voice, before stars carved brightness into the dark, there was a silence so absolute that even the concept of before begins to fade. The early universe was not the cold emptiness we know today, but a storm of heat, a dense ocean of particles colliding, merging, tearing apart again. In that first fraction of a second, after the Big Bang, everything that would ever exist was condensed into a seething cloud of potential. No form, no light, no separation, only pressure and energy moving in chaotic harmony. It was not yet a cosmos, not yet a place where light could travel, only the raw possibility of existence waiting to breathe. In that blinding density, light was trapped. Every photon born from the early fire was instantly caught by a particle, bounced, swallowed, scattered endlessly. The universe was too hot, too thick, too crowded for transparency. To speak of seeing in that age would be meaningless, because nothing could be seen. The cosmos was like a womb, an interior world sealed in heat and pressure, nurturing what would one day unfold into stars and galaxies. Then came patience. For nearly 400,000 years, that fiery fog expanded and cooled. The particles that once smashed into each other without rest began to slow their frantic motion. The first atoms, hydrogen and helium, took shape, delicate yet profound, their formation a moment of cosmic calm after unimaginable chaos. With atoms came something the universe had never known before: clarity. Space became transparent, and the light that had been trapped for eons finally slipped free, racing across the newborn cosmos. That light is still traveling today. Astronomers call it the cosmic microwave background, the oldest light we can see, a faint afterglow that fills the universe like a soft, ancient whisper. It carries within it the fingerprints of everything that came before, subtle ripples that reveal the universe's first structure. To modern instruments, it looks like static, a grainy texture that wraps around the sky. Yet behind that pattern lies the memory of creation's first breath, the moment the universe stopped hiding from itself. It's humbling to realize that this ancient light is everywhere, passing through you even now. It isn't bright enough to see with your eyes, but it's there, filling every corner of space, every atom of your body bathed in the echo of that first illumination. Scientists have mapped it in exquisite detail, creating what might be called the oldest photograph ever taken. A picture not of stars or galaxies, but of the universe as a newborn. Each tiny variation in brightness corresponds to the seeds of all structure, the first hints of the galaxies that would one day form. Those faint ripples are the beginning of everything familiar. Yet even this image, as ancient as it is, does not show the full beginning. Webb's golden mirrors, designed to see farther into time than any telescope before it, look beyond the era of the first visible light. It peers into the dark fog before clarity, into the moments when physics itself was in flux. The space before light is a place of mystery, where time and temperature, gravity and energy all began to take form. To look in that direction is to press against the very limits of what can be known. Scientists describe that early opacity as the cosmic dark age. But that phrase carries a quiet irony, because darkness was not an absence, it was preparation. It was the universe building the conditions for light to exist, for matter to find stability. Before there could be starlight, there had to be shadow. The atoms that would later ignite in stars were born in that darkness. The laws of motion, of heat, of gravity, all were refined there, in the hidden silence before illumination. Sometimes, when people look at images from Webb, they see galaxies scattered like jewels on velvet and assume they're seeing the start of everything. But those lights, ancient as they are, already belong to a universe that had learned to shine. Behind them lies an even older story, one written not in brightness but in potential. To contemplate that story is to feel something like vertigo, a sense that existence itself had to wait in the dark, that light had to earn its place. The thought that light had a beginning is almost strange to hold. We often think of brightness as eternal, as the opposite of nothingness. Yet there was a time when even photons were prisoners. The first true light, the cosmic microwave background, was not dazzling, but soft and even, like a sigh escaping from a long-held breath. It was not the blaze of stars, but the glow of freedom, the moment the universe learned transparency. In many ways, this light is still teaching us humility. Every observation, every deep space image is framed against its backdrop. It's the baseline of reality, the echo that reminds us how far we've come and how much we still don't know. Webb cannot see that far directly, for that light lies in wavelengths beyond its design. But it feels its presence in the deep structure of everything it captures. Each distant galaxy Webb observes carries the imprint of those first fluctuations. Each thread of the cosmic web was woven from the patterns frozen in that ancient glow. When scientists analyze the cosmic microwave background, they find evidence of subtle variations in temperature. One part of the sky just slightly warmer or cooler than another. Those variations may seem trivial, yet they are the reason we exist. Without them, the universe would have remained perfectly smooth, without contrast, without shape. No stars, no galaxies, no planets. Every mountain, every person, every heartbeat is the result of those tiny imbalances in the earliest light. In the gentle unevenness of the cosmic glow lies the origin of all complexity. Thinking of this can slow the breath, can make the mind quiet. The universe was once so young, so dense, so hot, that even light had to wait. Then, slowly, it learned to move, to travel, to tell stories across time. Each photon that Webb detects today began its journey in that first freedom. It has crossed billions of years, untouched, unbroken, still carrying the signature of that initial release. To see that light is to see endurance itself, the persistence of something that refuses to fade. But as far back as the cosmic microwave background reaches, it still does not touch the true beginning. Before that release, before atoms and clarity, there was a moment when time and space were stretching at speeds beyond comprehension, when the universe grew from smaller than a grain of dust to larger than a galaxy in a heartbeat. The physics of that moment are almost beyond language. What came before the first light is not emptiness, but transformation. The universe was rewriting itself, its laws shifting in ways that would define everything after. Webb cannot see that moment directly. No telescope can. But through its echoes, through the arrangement of galaxies, through the texture of ancient light, it can sense the shape of what came before. It's like standing at the edge of a foggy field just before dawn, feeling the cool air and knowing that the light will come, that something vast and beautiful is on its way, but not yet here. That is what it means to peer into the time before the first light. It is not to see, but to feel the universe preparing to see. As the darkness cooled, as the first atoms began to hum with stability, a deeper mystery was already fading into the distance. A phenomenon so strange, so brief, that it defined the entire future of space and time. It was a moment when the universe expanded faster than light itself, stretching the very fabric of reality beyond imagination. And in that blur lies perhaps the strangest phenomenon of all: cosmic inflation. In the first fraction of a second after the beginning, something extraordinary happened. Something so vast, so silent, so sudden that language can only brush against it. The universe took its first breath. Not the gentle inhale of life we know, but a breath so immense that it remade reality itself. Space didn't simply expand, it inflated, swelling faster than light, stretching from subatomic size to cosmic scale before a single second had passed. There were no stars yet, no atoms, no light, only expansion, pure and unrelenting, as if existence itself had exhaled for the first time. Scientists call this moment cosmic inflation. It is not a metaphor, but a theory born from the need to explain how something so immense could become so uniform, so perfectly balanced, so vast. Without it, the early universe would make little sense. The smoothness of the cosmic background radiation, the even distribution of galaxies across billions of light years, all point to a beginning that expanded faster than any ordinary process could allow. To picture it is to enter a strange kind of paradox. Nothing moved through space. Space itself was what was moving, stretching outward everywhere at once. In that instant, the scale of everything multiplied by inconceivable factors. What was once smaller than a proton grew to cosmic proportions. The energy of the early universe inflated the fabric of space-time like a balloon, each quantum ripple pulled into vast streaks of potential. It happened so quickly that even light, the universe's ultimate speed limit, could not keep up. The beauty of inflation lies not only in its vastness, but in its precision. Those tiny quantum ripples, fluctuations in the smallest scales of reality, became the seeds of everything that would ever exist. Where there was a slight excess of energy, gravity would later gather matter. Where there was a slight deficit, space would open wider. In those subtle wrinkles, invisible then, but enormous now, the first galaxies took their shape. Every spiral, every cluster, every world began as a whisper of uncertainty stretched thin across the newborn cosmos. It's astonishing to think that the structures Webb observes today, the brilliant arcs of light billions of years old, are not just remnants of ancient stars, but echoes of quantum accidents magnified to the size of galaxies. The same randomness that flickered within particles is now written across the sky in the architecture of creation. The stars that warm distant worlds, the dust that builds planets, the atoms in your own body, all emerged from those first ripples, frozen in place by inflation's breath. To study this process is to stand at the edge of comprehension. Inflation is not something we can observe directly. It happened too fast, too early, beyond the reach of any light. Yet its fingerprints are everywhere. The patterns in the cosmic microwave background, those faint ripples of temperature spread across the heavens, carry the signature of inflation's expansion. The distribution of galaxies, the symmetry of the cosmos, even the smoothness of space itself, all whisper of that first impossible surge. There's a quiet poetry in the idea that the universe began with a burst of instability, that perfection arose from chaos. In the smallest fluctuations of quantum energy, chance sculpted destiny. Those fluctuations were not predictable, not chosen, yet they became the outlines of everything. The same uncertainty that rules the subatomic world also shaped the cosmic one, as though the universe carried the fingerprint of probability into every scale of its being. When Webb peers deep into the early structures, when it reveals galaxies forming earlier and brighter than expected, it may be glimpsing the aftermath of that first inflationary moment. The smoothness and sudden complexity of those distant galaxies could be the echo of how space expanded, how energy condensed, how the quantum fog crystallized into form. Each observation, each faint patch of light, is a message sent from those first seconds, a fragment of that ancient breath still rippling through time. Inflation also reframes how we think about beginnings. The phrase Big Bang evokes an explosion, a single point erupting into emptiness, but inflation tells a subtler, stranger story. It suggests not a detonation, but a stretching, a swelling of the very fabric of reality. Space did not expand into something, it created the somewhere as it grew. Every inch of existence came from within itself, a self-generating burst that needs no outside space to expand into. The universe, in a sense, made room for itself to exist. That realization bends the mind. It means that what we think of as the cosmos, the entire stage of stars and galaxies, may have been born from a moment of pure geometry, a swelling of potential energy transforming into space and time. The rules we live by, cause, effect, direction, speed, were written in that moment when nothingness became capable of unfolding. Inflation is not merely a physical theory. It is the story of how possibility became form. To reflect on it is to feel small in the most beautiful way. For everything that now exists, from the glow of distant quasars to the heartbeat of a living creature, began as a tremor in a field of energy smaller than an atom. The simplicity of that idea carries something almost spiritual, that the vastness we see today was born from an infinitesimal murmur, that the entire cosmos was once contained within a vibration too faint to hear. There is something serene about this thought. Inflation, for all its violence and speed, was also balance. It set the initial conditions that allowed the universe to endure. Too fast, and everything would have scattered into cold emptiness. Too slow, and gravity would have crushed it back into itself. Somehow, it unfolded just right, as if the cosmos had found its own equilibrium between chaos and calm. The first breath was both a surge and a settling, a moment of wild expansion wrapped in harmony. When astronomers trace the faint radiation left over from those early moments, they find an almost perfect smoothness. Not exact, but near enough to perfection that it defies chance. That near perfection is what allows galaxies to form, stars to burn, planets to orbit. It's what allows life to arise and wonder about its own beginnings. Everything is tuned to the echoes of that breath. Sometimes, late at night, it helps to think of the universe as still breathing. Expansion continues, not as violently as before, but steadily, rhythmically. Space grows between galaxies, light stretches as it travels, time unfolds in a slow exhale that began 13.5 billion years ago. Inflation may have ended, but its legacy endures, a quiet reminder that we live within a single, ongoing breath of creation. What Webb observes now are the distant ripples of that first expansion, patterns carved into the deep structure of space. Its mirrors reflect not only light, but the motion of time itself, the long aftermath of that first breath still echoing in the fabric of reality. And yet, there's a lingering question, soft but insistent, like the pause between one breath and the next. Those quantum fluctuations that started it all, are they truly gone, or do they still hum beneath everything, faint and eternal? Because if inflation began with a whisper, perhaps those whispers are still echoing, shaping the cosmos in ways we've only begun to sense. At the smallest scales of existence, the universe stops behaving like a machine and begins to behave like a dream. Certainty dissolves, replaced by something far more fluid, a restless shimmer of possibilities that blink in and out of being. Down there, beneath the reach of sight or even sense, reality doesn't stay still. It flickers, it hums, it trembles with energy so subtle and constant that even nothingness is never truly empty. Physicists call this realm the quantum world, but that name hardly captures its strangeness. In this deep, invisible layer of existence, everything is both there and not there. Particles appear from nowhere, vanish, reappear, all within the blink of a moment too brief to measure. Space itself seems alive, breathing in these fluctuations like the surface of a lake touched by the wind. No single event can be predicted exactly, only the probability of what might happen next. It's less a set of rules than a rhythm, a quiet pulse beneath the structure of everything. From that flickering sea of uncertainty, the entire universe may have risen. That's one of the most haunting ideas modern physics has dared to suggest, that existence itself was born not from fire or design, but from a quantum tremor, a momentary fluctuation in a field that couldn't hold still. In a void that wasn't truly void, energy briefly borrowed from nothing, expanded, and never gave itself back. What began as a ripple became a universe. In this view, the Big Bang was not an explosion, but a fluctuation grown too large to fade away. A vibration in a quantum field, magnified beyond comprehension, became the space-time we now inhabit. That tremor didn't happen in space because space did not yet exist. It created space. It didn't occur in time because time itself was born from it. In that sense, the universe didn't appear somewhere or sometime. It was the appearance itself. There's something deeply poetic about that. The idea that all the galaxies, all the light, all the lives that would one day emerge came from the most delicate instability imaginable. A whisper in the silence before silence, a quantum sigh that refused to fade. It feels less like a mechanical process and more like a breath of spontaneous creation, where reality blinked open its own eyes for the first time. When the James Webb Space Telescope peers into the faintest, oldest light, it isn't only looking backward through history. It is, in a sense, looking downward, into the foundation of what made history possible. The distant galaxies it sees, the ones formed in the first few 100 million years, still carry the patterns seeded by those initial fluctuations. Their shapes, their distributions, their clustering, all are echoes of that first quantum murmur magnified to cosmic size. The telescope's images, then, may hold more than a record of what came after the Big Bang. They may carry subtle hints of what existed before it, or more precisely, what preceded the conditions that made the Big Bang possible. The faint irregularities in the background light, the gentle unevenness in how matter gathered, could be the fossilized memory of the universe's own quantum birth. It's an eerie idea that the universe itself might be a kind of quantum event, stretched to infinity. That the same rules governing the uncertain dance of subatomic particles also shaped the birth of stars and galaxies. What we call reality might be the grandest expression of quantum behavior, scaled up to cosmic size. In that sense, the universe is not a static structure, but a living wave, still rippling outward from its point of origin. That notion also carries a strange kind of intimacy. The quantum fluctuations that gave rise to everything never truly went away. They are still happening everywhere, at every moment, inside every atom, and between every photon of light. The same restless energy that once birthed the universe continues to hum in the fabric of your own body. Every breath you take, every flicker of thought in your brain occurs within that same shimmering field of uncertainty. You are, quite literally, made of quantum echoes, the residue of the universe's first tremor. It's hard not to pause there, to let that thought settle, because it blurs the boundary between the cosmic and the personal, between the infinite and the intimate. The particles that make you were once part of that primal fluctuation. The space you occupy, the time you move through, the laws that bind you, all of them are ripples in the same vast sea. You are not simply in the universe. You are part of the pattern that allows it to exist. When we talk about nothingness, we often imagine emptiness, silence, absence. But in quantum physics, nothingness is anything but empty. Even in the deepest vacuum, fields still vibrate with potential. Tiny virtual particles appear and vanish, borrowing energy for a heartbeat before returning it to the void. This restless background noise is the baseline of existence, the canvas on which reality paints itself. Out of that constant fluctuation, something stable eventually emerged. It's as if the universe settled on a single note after an eternal hum of possibilities. That note became everything. Some scientists believe that our entire universe may be just one of countless fluctuations, each creating its own version of reality, each inflating into a separate cosmos. Others suggest that our universe could eventually dissolve back into the quantum field it came from, returning to that primordial murmur from which it rose. Whether those ideas are true or not, they carry a strange comfort. Because even if everything ends, even if galaxies fade, stars die, and space grows cold, the underlying song remains. The quantum hum never stops. In a way, Webb's deep images are portraits of that hum. Every pinprick of light in those infinite fields is a frozen vibration, a note in the ancient symphony of creation. The telescope doesn't just show us what's out there, it shows us what's underneath everything. Each photon captured by its mirrors began as an expression of quantum energy, born from uncertainty, guided by chance, traveling billions of years only to end its journey as a single flash on a golden mirror. There's a quiet wonder in realizing that we're listening to echoes that began before light itself had meaning. Those photons are messengers from the edge of time, carrying whispers of what it felt like to become real. The universe was not built in an instant, but it began in a shimmer, a moment where possibility found form. That shimmer never really ended. It continues, softly, in every corner of space. To look at the stars, then, is to watch the quantum world made visible. Every glint in the sky is a memory of instability transformed into light. The cosmos is not the opposite of chaos. It is what chaos looks like when it learns to sing. Perhaps that's why there is something so human in our desire to look upward. We are, in a sense, trying to find the source of our own pulse, that original tremor that set everything in motion. To trace the universe back to its quantum beginning is to look for the spark that made it possible for anything to exist at all, including us. Those murmurs of quantum creation are still with us, faint but constant. The background hum of being, the low vibration beneath the silence. When Webb gazes into the darkness, what it truly sees is the afterglow of those first fluctuations, the moment the void learned how to speak. To feel the weight of that is to sense the strangeness of seeing so far back that time itself seems to thin. Because in those depths, what Webb captures isn't only the beginning of light, it is the memory of the moment before beginnings, the breath before the first word, the shimmer before the song. And to truly understand what that means, we have to take one final step back and ask the question that hums beneath every image Webb has ever sent home. What does it really mean to see the beginning of time? Every photon that reaches the James Webb Space Telescope carries a secret. Trapped within its faint glow is not just a record of where it came from, but when. Each beam of light that touches those golden mirrors has been traveling for millions, sometimes billions of years, across an expanding universe that stretches the meaning of distance itself. The telescope does not simply collect light. It gathers moments, little fragments of history that left their source long before Earth was even born. To see through Webb's eyes is to see the universe not as it is, but as it was. Every image is a conversation with the past, a whisper from a time when galaxies were still forming, when stars were only beginning to burn. When scientists speak of looking deeper, they mean looking older. For the farther we peer into the void, the further back we reach into time itself. In that sense, the telescope is less a window and more a time machine, its mirrors polished to catch the ancient ghosts of creation. The concept seems simple enough. Light takes time to travel. But the deeper truth is far stranger. The beam that left a galaxy 13 billion years ago has spent all that time moving through expanding space, its wavelength stretched thinner and colder with every passing eon. By the time it arrives, it has been transformed, not only by the journey, but by the very evolution of reality around it. The colors Webb records are time made visible, a rainbow stretched across the history of everything. There's something deeply moving about that. When we see an image of a distant galaxy, glowing softly, its spiral arms delicate and faint, we are not seeing it as it exists now. That galaxy might be gone, consumed by collision or darkness. What we witness is its memory, the final image it cast across the cosmos before vanishing. The light continued on, unaware of what became of its source, until it met the gaze of a machine orbiting a small blue planet on the edge of a modest star. To gaze into those images is to experience a kind of temporal vertigo. You begin to realize that the universe doesn't have a single shared now. Every point in space holds its own slice of time, and what we call the present is merely a collection of countless pasts arriving together. The light from a nearby star may be only a few years old, while the glow from a distant cluster predates our entire species. The night sky is a collage of different eras, stitched together by distance. In that way, Webb's great gift is not just its ability to look far, but its ability to make time visible. Each deep field image, those haunting, crowded portraits filled with thousands of galaxies, is a timeline in a single frame. The ones that appear larger and brighter are closer to our moment. The smaller, redder specks are older, their light stretched by cosmic expansion until it fades into infrared. What we see is time unfolding before us, each pixel another century, each glow a chapter written long ago. It changes how we think about existence itself. We tend to imagine time as something that moves forward, a river flowing in one direction from past to future. But in Webb's view, time feels more like a landscape, vast, layered, filled with places that still exist, even if we can never return to them. The telescope doesn't travel through time, it reveals it. It shows that the past is not gone but simply far away. Its light still drifting through the dark, waiting to be seen. When you look at one of Webb's images, you are seeing what time looks like when stretched to infinity. The deep red glow of a primordial galaxy is the color of distance, the shade of patience measured in billions of years. The faint smudges between brighter stars are not imperfections, but fossils of light, preserved since the dawn of everything. The universe is not quiet. It is constantly sending us its history, written in light across the vacuum of space. This realization can make even the smallest moment on Earth feel extraordinary. Because the photons that leave your face right now, bouncing off your skin, scattering into the air, will continue traveling outward long after you are gone. Some may cross the solar system. Some may wander into the interstellar dark. For a distant observer, you too could one day be a ghost of light, a brief spark frozen in time, a memory that still glows. Perhaps that's why looking through Webb's eyes feels almost spiritual. It reminds us that everything that has ever existed leaves a trace. Time doesn't erase, it records. Every instant that has passed still echoes somewhere, in some wavelength, in some distant particle of light. The telescope doesn't just reveal ancient galaxies, it reveals the continuity of being itself. But there's a deeper, more unsettling thought beneath all this beauty. If we can see time, if we can study its oldest fragments and trace its earliest steps, can we ever truly understand it? What is this flow we're all caught in? Is time a fundamental part of the universe, or merely an illusion born from our limited perception? Einstein showed that time bends, stretches, slows down, and even stops under certain conditions. To a beam of light, there is no passage of time at all. Its entire journey from creation to detection happens instantaneously. So what we call the past might not be gone. It may simply exist in another frame of reference. That means the galaxies Webb sees, those ancient lights from the beginning of creation, are not just old, they are timeless. They still exist, just not here. The light we see now is the intersection of our present with their past, a meeting point between two realities. Time is not a line but a tapestry, woven from threads that cross and touch in ways our minds can barely grasp. It's humbling, almost disorienting, to think that we're looking at the same universe that was and is and will be all at once. The photons arriving at Webb are like the slowest raindrops imaginable, falling from a storm that happened billions of years ago, finally reaching the ground. Each one is a messenger, telling us that the past never really leaves. It only moves further away, fading not into nothingness, but into distance. Take a moment to think about that. The act of seeing, at its core, is an act of time travel. Every glance is a journey through history, whether it's the microseconds it takes light to reach your eyes from the walls around you, or the billions of years it takes to arrive from a galaxy at the edge of the observable universe. Every image, every reflection, is a layered record of moments passing through each other. The world we perceive is already history, unfolding so quickly we mistake it for the present. Through Webb's golden mirrors, that illusion begins to dissolve. The telescope teaches us to see differently, not just outward, but backward, inward, across time. It shows us that the universe doesn't simply age, it accumulates, that every moment, no matter how fleeting, becomes part of something larger, something that never truly ends. So perhaps the question is not how far Webb can see, but how deeply. For what it reveals is not merely space, but duration itself, the architecture of time laid bare in light. Each pixel in its images holds an eternity, each beam of light a memory. The telescope doesn't just photograph galaxies, it photographs becoming, the slow unfolding of everything that ever was. And somewhere within those frames, caught between what is visible and what has already vanished, lies the softest question of all, one that waits at the edge of thought. If we can see time so clearly, if we can hold it still within a single image, could we also glimpse how it might one day fade? Because where time has a beginning, it must also have an end. And that is where our journey turns next, toward the horizon, where even light begins to fall silent. The universe is stretching, not gently, not steadily, but with a quiet urgency that grows stronger with every passing epoch. The space between galaxies isn't just widening, it's accelerating, pushed apart by something we do not understand, something invisible yet overwhelmingly dominant. This force, which scientists call dark energy, acts like a silent wind blowing through the cosmos, expanding the fabric of space itself. The galaxies we see drifting away are not moving through space. Space itself is moving, carrying them outward like leaves on an endless tide. At first, this discovery seemed subtle, almost delicate, a faint acceleration noticed in the fading light of distant supernovae. But as observations deepened, the truth became undeniable. The universe is not slowing down after the Big Bang as once believed. It's racing outward, faster with time, an ever-expanding breath that never exhales. That realization changed everything. It meant that the cosmos has no plan to settle, no promise of stillness. It is rushing toward a future where everything familiar becomes unreachable. Through Webb's golden eyes, this expansion is visible in the faint red glow that stretches the light of distant galaxies. What began as brilliant blue in the early universe now arrives as soft infrared, its wavelength pulled longer by billions of years of motion. Every photon Webb captures carries the signature of this stretching, a cosmic echo of acceleration. The farther away a galaxy lies, the redder its light becomes, until at a certain distance, it slips beyond what even Webb can see. Those galaxies aren't gone. They are simply lost to time, carried away on the swelling tide of space, faster than their light can ever return. It is a strange kind of vanishing, one that happens not because of destruction, but because of separation. In the far future, galaxies that once shared the night sky will fade from view, their light diluted into invisibility. The universe will grow dimmer, lonelier. The great cosmic web of light that now connects everything will unravel strand by strand, until only the closest galaxies remain visible, then none at all. The stars themselves will still burn for a time, but the vastness between them will swallow their light. For future observers, if there are any, the cosmos will appear static and empty. They will look up and see only darkness, perhaps a faint scattering of nearby stars, unaware that beyond that black horizon lies an infinity they can no longer touch. The story of the universe will still exist, but the pages will have drifted too far to read. The golden age of cosmic visibility, the era of telescopes and discovery, will have ended long before they were born. That realization casts a quiet melancholy over Webb's mission. Its images are not just scientific data. They are acts of preservation. The galaxies it reveals, glowing faintly from the edge of time, may never be seen again. In a sense, the telescope is photographing ghosts not only from the past, but for the future, saving glimpses of a universe that will one day fade beyond all reach. The cosmic childhood it captures is already vanishing into darkness, not because the light has died, but because it is moving away faster than time allows us to follow. It's comforting, though, to know that light does not truly disappear. It continues to travel, endlessly, across the expanding void. Even as the universe stretches, those photons will keep moving forward, carrying the memory of everything that ever was. Somewhere in the cold, unending dark, they will still exist. Silent travelers bearing messages no one may ever read. Perhaps in that persistence there's a kind of grace. The universe may dim, but it does not forget. To imagine that fading is to feel a kind of cosmic nostalgia, a tenderness for the light that once filled everything. The galaxies Webb observes today are young compared to what they will become. They are still close enough for their light to reach us, still within the shrinking window of connection. But as time expands, that window closes. The future universe will be a quieter place, stripped of color and motion, where light itself is stretched so thin it can no longer carry warmth. Yet even in that silence, something remains. The background glow, faint, uniform, eternal, will continue to whisper across space. It is the afterglow of creation, the leftover warmth from the Big Bang, stretched to microwaves by the same expansion that now drives galaxies apart. It will never vanish entirely, only fade softer, colder, thinner, until it becomes indistinguishable from nothing at all. But even that nothing will hum faintly with memory, a cosmic echo that refuses to fade completely. In that far future, when the night sky grows empty and still, what will it mean to see? What will it mean to remember? Perhaps vision will no longer depend on light, but on imagination, on the records left behind by telescopes like Webb, frozen glimpses of what once was. The golden mirrors, orbiting silently in our era, are not just instruments of observation. They are keepers of memory. They show us what the cosmos looked like when it was young, so that when the light finally leaves us, we will still know what it felt like to see. There's a quiet symmetry in that thought. The telescope reveals the universe's earliest moments, even as it bears witness to its gradual dimming. It stands at a midpoint between the first light and the last, between the cosmic dawn and the slow twilight to come. Webb's mission, then, is not just scientific, it's elegiac. It captures the light before it fades, the stories before they are lost to distance. It reminds us that every act of seeing is also an act of remembering. Perhaps that is why the images Webb sends home feel so haunting. They are filled not only with color and form, but with time. Each galaxy is a farewell, a light that left home billions of years ago and will never return. Each frame is a relic of a universe that is already moving beyond our reach. The beauty of those pictures lies not only in what they show, but in what they imply. That everything we know is temporary, yet eternally recorded in the light. Even as the cosmic expansion continues, even as the stars drift apart, there's a sense that the universe is not truly dying. It is simply changing tempo, slowing into silence. The acceleration that drives galaxies away is the same motion that once brought them together, the same pulse that began with the Big Bang. Creation and fading are two halves of the same rhythm, an inhale followed by an exhale, the slow breath of existence. Somewhere, billions of years from now, a future intelligence might find traces of our light, the photons that left our telescopes, our cities, our sunlit days. They might drift across the intergalactic dark, stumble upon that faint evidence, and wonder who we were. In that moment, they too would be looking back in time through the same cosmic haze that now fills Webb's mirrors. So even as the future grows dim, even as the universe slips away into darkness, memory endures, written in the quiet persistence of light. Every photon Webb captures becomes part of that record, a thread in the tapestry of cosmic remembrance. The telescope's purpose is not just to see, but to keep seeing on our behalf, long after our eyes have closed. Because one day, the light will fade. The galaxies will drift too far to reach. The universe will fall into shadow once more. But even then, something remains, the faint trace of what once was, carried endlessly through the expanding dark. And it is there, in that endless quiet, where our story continues. For even in the dimming future, the light still remembers. But perhaps memory itself holds a deeper secret, one that lies not in what fades, but in what endures, the subtle weave of time that keeps every moment connected, even across the dark. Light never truly disappears. It doesn't shatter. It doesn't burn out. It only drifts, softens, cools into longer breaths until its presence becomes less a glow and more a murmur. The universe remembers through light. Every photon, every trembling particle of it carries an imprint of where it's been, how long it's traveled, and what it's seen. When Webb collects that faint radiation from the farthest corners of space, it isn't just recording brightness. It's reading memory, ancient memory. Some of those photons began their journey more than 13 billion years ago, leaving their stars when the cosmos was still young enough to fit inside a single galaxy's reach. Since then, they've crossed oceans of space that never stopped expanding. Their paths stretched, their energy thinned, their color reddened, until the once blue flame of a newborn star now arrives as a soft pulse in the infrared. The light hasn't vanished. It's only been slowed, elongated, cooled by the rhythm of a growing universe. It's like a voice echoing across a vast canyon, drawn out into something slower, deeper, yet still carrying the shape of its original sound. This stretching, known as redshift, is more than a measurement. It's the universe's handwriting, a record of its movement through time. Every photon Webb detects has been gently pulled apart by the fabric of space itself, as though the cosmos is inscribing its story directly onto the light. The farther back Webb looks, the more those wavelengths lengthen, turning what once was a flash of ultraviolet brilliance into the faint, ember-like glow that reaches its mirrors. The light is still the same light, only older, slower, patient. To see it is to reach backward across the centuries, to touch something that should have been untouchable. In that sense, astronomy isn't really about looking outward, but inward, into the long memory of existence. Those ancient beams are like time capsules, small parcels of truth traveling through expanding darkness to remind us where everything began. Each one carries the signature of its birth, the temperature of the gas it passed through, the motion of the galaxy it left behind, the shadows of other stars that crossed its path. Collect enough of them, and the story begins to take shape, a narrative written in light, spanning billions of years, unfolding right in front of us. What's strange, almost tender, is that this light isn't just telling us about what was once bright, it's also telling us about what's no longer there. Many of the stars whose photons now strike Webb sensors have been gone for ages, burned out or torn apart. Their matter scattered, recycled into new generations of suns and planets. Yet their light remains, still in motion, still arriving, still whispering that they once existed. In that way, the universe keeps its own archive, not in stone, not in memory, but in the persistent travel of light. Every moment you look up at the night sky, you're not seeing what is, but what was. The starlight reaching your eyes is already old. Even the light from the sun carries an 8-minute delay, a tiny distance in cosmic terms, but a reminder that everything we see is filtered through time. What we call now in the universe is always slightly behind, a collection of pasts stitched together into a present that only seems immediate. When Webb gazes deeper, that delay stretches from minutes to millions, even billions of years. It becomes less a look into space and more a journey through time's long corridor. It's humbling to think that light remembers when nothing else can. Planets crumble, stars explode, galaxies drift away, yet photons continue to travel, carrying their ancient stories. They never rest, never decay in the way we understand decay. Even when they lose energy, they persist as something quieter, a faint hum, a remnant frequency woven into the background of everything. The cosmic microwave background, that soft radiation filling every corner of space, is exactly this. The oldest light, stretched beyond recognition, yet still glowing faintly with the warmth of the universe's beginning. Webb's instruments are tuned to listen to those stretched whispers, to see what the naked eye cannot. Through its mirrors, we witness the after images of the first galaxies, the first sparks that dared to burn in the darkness. Every color, every shape in its deep field portraits is a piece of that ongoing memory. The telescope doesn't just observe, it remembers for us, capturing echoes before they fade entirely. Each frame is a conversation between the present and the past, between what remains and what has long vanished. There's a quiet beauty in knowing that nothing luminous is ever entirely lost. Even as the universe cools and expands, even as stars collapse and light grows faint, the record remains, however stretched. Time transforms brightness into shadow, but not into nothing. The same light that once danced across the surface of a forming world or spilled from a dying sun might still be traveling somewhere, unseen, unforgotten. Somewhere in the endless dark, it's still carrying its memory forward. In that sense, light is both messenger and monument. It doesn't simply reveal what happened, it is what happened. When Webb receives a photon, that particle isn't a representation of the past. It is the past arriving in the present. That's the quiet miracle of it all. We are not merely observing history, we are physically touched by it. The light that left a galaxy billions of years ago now lands gently on our detectors, our retinas, our minds. Time becomes tactile, almost intimate. There's something profoundly human about our need to read these messages, to decode the faint relics of a story that predates us by eons. Perhaps we look to the light because we, too, are creatures of memory. Our lives are small, fleeting, yet we leave traces, words, photographs, the warmth of our presence in someone else's recollection. In that way, we share something essential with the photons that cross the void, a desire to endure, to be seen, to be remembered. Every image Webb sends home is therefore both a discovery and a memorial. It shows us what once was, but it also reminds us that the act of seeing is the act of remembering. The telescope doesn't just map the universe, it participates in its memory. Its golden mirrors reflect not only starlight, but the persistence of curiosity, the same impulse that drove us to ask what lies beyond. The cosmos remembers through photons, and we remember through wonder. To look at those faint red arcs in Webb's deep field is to listen to the oldest song ever played, a melody written in frequency and time, stretched thin but still resonant. The music of the beginning still plays, even as it fades into the background. We hear it not with our ears, but with our instruments, our understanding, our longing. Perhaps that's why the light feels so alive, even after billions of years. It doesn't age in the way we do. It changes, transforms, but never ceases. It stretches and cools, yet it continues to move forward, as though time itself can't stop it. Every photon is a survivor, carrying fragments of eternity, proof that existence leaves a trace no darkness can erase. Eventually, the stars will die, galaxies will dim, and space will drift toward silence. But the light, faint, stretched, almost imperceptible, will still be out there, flowing endlessly. Even when the last eye has closed, the universe will continue to remember itself through the motion of light. So, when we speak of seeing the cosmos, we're not just describing what's visible, we're participating in its remembrance. We are part of the same continuum of light, the same story written in motion and decay, presence and absence. The universe remembers through photons. We remember through awe. And yet, behind all that brightness and memory, beyond even the oldest glow of the Big Bang, there lies something deeper. A stillness that light itself cannot touch. A silence vast enough to hold everything that ever was. It waits beyond illumination, patient, unbroken, where the echoes finally rest. Between every galaxy stretches a darkness so deep it seems to devour thought itself. It's not the gentle darkness of a moonless night or the quiet pause before dawn. It's older, heavier, something almost sacred in its stillness. Out there, between the grand islands of stars, lies a silence so complete it feels less like absence and more like a presence, a vast, patient awareness that has been listening since the beginning. When we speak of the cosmos, our minds fill with light. Suns igniting, galaxies spinning, nebulae blooming like flowers of fire. Yet most of the universe isn't made of light at all. It's made of the spaces between, the endless stretches where nothing shines. The dark matter and thin gas that float between galaxies form an ocean of near-nothingness, an expanse so delicate it's almost invisible, but never truly empty. Within that quiet sea drift particles older than memory, photons too weak to stir the eye, waves of radiation stretched until they fade into whispers. Webb's mirrors, polished to a precision finer than a human hair, can feel that silence, not by hearing it, but by sensing what remains when the light is almost gone. Every exposure it takes captures not just the brilliance of stars, but the hush that surrounds them. The telescope listens to the space between notes, the pauses between cosmic sentences, the breath the universe takes before speaking again. That silence isn't simple void. It carries traces of everything that's ever been. Ghostly afterglows of galaxies long vanished, stray particles drifting from ancient collisions, the faint hum of gravity weaving through the cosmic web. Even emptiness has structure. The space between the stars bends, curves, and trembles under the influence of what it holds. Gravity still tugs there, shaping invisible rivers that connect galaxy clusters across unimaginable distances. Energy still passes through, soft as fog, thin as thought. To call it quiet almost feels like a misunderstanding. It's not the silence of nothing, but of everything resting together in balance. Within it, the motion of the universe slows into a kind of breath. Expansion and stillness, radiation and shadow, woven so delicately that it becomes almost musical. The stars sing their fierce, bright songs, and between them, this cosmic stillness hums the low refrain that gives the melody meaning. There's a paradox to it, something deeply human. We look into the darkness and feel a pang of loneliness, as though the absence of light means the absence of life. But the more closely Webb peers into that blackness, the more alive it seems. The intergalactic medium, invisible to the naked eye, glows faintly in radio waves and X-rays, pulsing with the distant energy of creation's aftershock. It's the echo of the Big Bang still stretching outward, diluted yet unbroken. The silence, then, is not the end of sound, but the soft continuation of it, a fading heartbeat that never quite stops. Astronomers often describe the universe as a web, with galaxies as its luminous knots. The space between them is the thread, thin, unseen, yet holding everything together. Without that dark framework, the bright points would drift apart, their stories unconnected. The emptiness, it turns out, is the reason anything endures. It gives form to the light, context to the chaos. It defines the stage upon which everything dances. Maybe that's what makes the silence between stars feel so humanly resonant. We live surrounded by noise, thoughts, screens, motion. Yet what gives our lives meaning are often the pauses, the moments when we stop to breathe, when the mind grows still enough to sense the quiet beneath the motion. The cosmos mirrors that rhythm. It burns with creation, then rests in stillness, only to flare again somewhere else. Its silence is not death, but recovery, renewal, waiting. When Webb photographs a distant cluster, it's easy to focus on the glittering galaxies, those spirals and smudges that steal our gaze. Yet look closer, past the brilliant shapes, and you'll find that what lies between them fills most of the frame. Soft, velvety darkness threaded with faint smears of light, each pixel whispering that even emptiness has a story. The telescope doesn't just capture what's there, it reveals the delicate boundary between something and nothing. This intergalactic quiet carries another kind of beauty, the beauty of restraint. The universe, in its immensity, could have been an endless blaze, a storm of radiation without rest. But it isn't. It learned to hold back, to balance expansion with stillness, fire with silence. In that equilibrium, creation found its harmony. For every star that burns, there's a shadow that cools it. For every sound that echoes, there's a silence that receives it. In some ways, Webb's greatest discovery isn't in what it sees, but in what it feels through absence. Those empty stretches between galaxies remind us that light, though extraordinary, is not the whole story. The darkness shapes the path of light, gives it a place to travel through, gives it contrast so that its brilliance can be seen at all. Without shadow, there is no perception of glow. Without stillness, there is no song. Even now, billions of miles from home, Webb drifts in that silence, suspended in a pocket of gravity's calm at the L2 point. It moves through space that is colder than comprehension, hearing nothing but the faint hum of its own machinery. Yet in that quiet, it listens to the universe's oldest conversations. Its golden eyes gather whispers from distances no human voice could reach. It translates the unspoken language of darkness into something we can see, something that reminds us how full silence can be. Perhaps that's the most profound truth hidden in the cosmic hush. Silence is not absence, but connection. The gaps between galaxies are the same as the pauses between heartbeats, the spaces between thoughts, the distance that allows things to exist separately, yet still belong to one another. The universe breathes through those gaps. It remembers itself in the quiet. Some scientists speak of the cosmic background, a sea of radiation left from the dawn of time, faint yet omnipresent. Beneath that, there is an even softer background, a gravity field that hums too low to hear, shaping everything in silence. Webb's instruments cannot capture that hum directly, but its presence ripples through the images, subtle distortions that reveal how even the quiet bends light, how even stillness has weight. So when we talk about the darkness between stars, we're really speaking about the universe's heartbeat, slowed to its gentlest rhythm. It's not an emptiness that waits to be filled, but a fullness that doesn't need to announce itself. The light depends on it, just as we depend on the quiet moments that allow us to see clearly. In the silence between the stars, all motion becomes meaning. It's where the noise of existence softens enough for understanding to emerge. Webb, in its steady watching, reminds us that the cosmos isn't only a story of creation and destruction, but of balance, the luminous and the dark, the spoken and the still, all woven into one continuous breath. And perhaps if we listen closely enough to that cosmic stillness, we might begin to hear not nothingness, but the faint outline of something greater. A hidden rhythm that connects the galaxies and the spaces between them, the stars and the shadows they cast. A pattern that says even silence is part of the song. Across the dark expanse of the universe, where galaxies drift like embers in an infinite night, a pattern quietly unfolds, vast, delicate, and astonishingly alive. It isn't chaos that fills the cosmos, but structure. Beneath the scattered light, beneath the glow of stars and the hush of intergalactic darkness, lies an intricate design, a cosmic web spun from threads of gravity and time. The deeper astronomers look, the more they realize that the universe is not a random scattering of matter, but a single interconnected organism, a vast body whose veins are galaxies and whose breath is expansion itself. Webb's mirrors, golden and patient, have begun to trace those threads. Every faint glimmer it captures belongs not just to a lone galaxy, but to a network stretching billions of light years. Astronomers call it the cosmic web. It's composed of filaments, long, gossamer bridges of dark matter and gas, where galaxies cluster like dewdrops along invisible strings. Between them lie enormous voids, silent and nearly empty, yet essential in defining the shape of everything else. From afar, the universe resembles a brain, or perhaps the roots of some unfathomable tree. This architecture did not emerge by accident. It began as the faintest ripples in the early universe, when matter was evenly spread, yet imperfectly so. Tiny variations in density, left behind by inflation's quantum murmurs, became gravitational seeds. Over billions of years, those seeds drew matter toward them, pulling gas, dust, and dark matter into the long, curling filaments that now bind galaxies together. Webb's observations, combined with maps made by other instruments, reveal these filaments in ever greater detail, each one a frozen river of gravity guiding the motion of stars. It's humbling to know that everything familiar, every world, every sun, every atom that forms a thought, rides upon one of those filaments, part of a structure so immense it defies imagination. We are not suspended in isolation, but woven into a tapestry that connects all corners of the universe. Even the emptiness between galaxies is shaped by the tension of those cosmic threads, as if the universe itself were a grand loom, weaving light and darkness into form. There's something profoundly organic about it. The filaments twist and branch, intersecting at dense nodes where galaxy clusters bloom like luminous flowers. The patterns repeat across scales, from the delicate scaffolding of molecules to the geometry of the largest cosmic structures. It's as though the same principle, the balance between attraction and expansion, order and chaos, governs all levels of existence. Webb's discoveries deepen this intuition, suggesting that the universe behaves less like a machine and more like a living thing, evolving through feedback, cooperation, and tension. To stare at these patterns is to confront a mirror of ourselves. The neurons in a human brain, seen through a microscope, resemble the distribution of galaxies across the sky. Both are networks built for communication, systems that exchange energy and information. Some scientists have even speculated, cautiously, poetically, that the universe could be processing information the way a mind does, its structure allowing energy to move efficiently, to organize, to remember. Webb doesn't prove this, of course, but its images invite the thought that consciousness might not be confined to life, but reflected in the way the cosmos organizes itself. Even in the cold mathematics of cosmology, there's a strange sense of purpose embedded in the Webb's design. Gravity, that quiet sculptor, has no awareness, yet its pull creates beauty. Each filament, though invisible to our eyes, serves as a channel through which galaxies form, grow, and merge. Like rivers nourishing the land, these gravitational streams feed the birth of stars. Light itself flows along them, bent by their mass, tracing their outlines through subtle distortions, the phenomenon known as gravitational lensing. In those distortions, Webb glimpses the unseen bones of the universe, the dark matter scaffolding upon which everything luminous hangs. There's poetry in thinking of dark matter not as emptiness, but as the invisible hand shaping existence. Without it, galaxies would drift apart, unable to cohere. Without it, the cosmic web would unravel. The unseen, it seems, gives structure to the seen, a truth that echoes far beyond astronomy. The universe teaches that presence and absence, matter and void, are not opposites but partners in creation. As Webb peers deeper, it doesn't just see the web's geometry, it begins to sense its rhythm. Galaxies within the filaments move not randomly, but as part of a cosmic choreography drawn toward nodes where gravity thickens. These meeting points are the universe's great cities, clusters of thousands of galaxies bound together in gravitational communion. Between them stretch gulfs of stillness, where matter is scarce and time seems to slow. The balance between motion and rest gives the cosmos its texture, a pulse too vast for us to feel directly, yet faintly echoed in our own biological rhythms. Perhaps that's why, even across unimaginable distances, the cosmic web feels strangely intimate. To know that our galaxy, the Milky Way, is one luminous thread among countless others is to feel both small and connected. Our position in the web isn't special, yet it matters, because every node, every spark contributes to the whole. We are, in a literal sense, part of the same fabric that shaped the first stars. The atoms in our bodies once flowed through those ancient filaments, caught in the gravitational rivers that link the earliest galaxies. We have always been part of that web, not merely observers of its beauty, but expressions of it. There's a quiet thought that arises when considering this structure. Maybe the ghosts of creation are not only the distant lights Webb collects, but the pattern itself, the invisible geometry of being. The universe's memory may not live only in photons, but in the way everything connects to everything else. Each filament is a story, each galaxy a word, and together they compose a sentence that the cosmos has been writing since its first breath. The longer we look, the more that sentence seems to say something both profound and tender. That chaos gives birth to connection, that distance does not erase unity, that even silence has structure. The web holds these truths without needing to explain them, as if existence itself prefers to speak through form rather than language. As Webb's data continues to unfold, the cosmic web grows clearer, revealing threads thinner than we once thought, patterns more intricate than any human map. Yet for all its precision, what moves us most is the feeling it evokes, that we are witnessing not randomness, but resonance. The cosmos hums with order, but not the rigid kind. It's a living order, fluid, flexible, breathing. The same forces that shape galaxies also shape meaning, echoing in the human urge to connect, to belong, to understand the whole by finding our place within it. When the telescope gazes into those depths, it isn't only revealing the structure of matter, it's holding up a mirror to the structure of thought. The web that binds the cosmos may be the same web that binds consciousness, both made of invisible connections, both alive with the pull of curiosity and the flow of energy. Perhaps that's the true revelation of Webb's vision. The universe, in all its complexity, is not a solitary expanse, but a network of relationships. Light, gravity, matter, and time are not separate elements, but intertwined strands of one great design. To see this is to understand that nothing, not even emptiness, stands alone. The telescope floats now in the cold silence of space, its golden mirrors gathering light that has traveled for billions of years, weaving those photons into images of patterns too vast to hold in a single thought. Yet, in a quiet way, the observer and the observed are part of the same weave. And that brings us closer to the final layer of the story, the one not made of galaxies or gravity, but of awareness itself. Because for all the universe's grandeur, its web is only complete when something within it looks back. Every image Webb sends home feels at first like a window, a golden frame opening onto the infinite. Yet as your eyes adjust to the colors and the delicate shapes of distant galaxies, that illusion shifts. What begins as looking outward becomes looking inward. The light that travels across billions of years doesn't simply reveal what's out there. It traces a path that leads straight back to us. Every spark, every swirl of gas, every collapsing star Webb captures carries something achingly familiar, the same raw material that built our bodies, our breath, our thoughts. To gaze into the cosmos is to meet your own reflection written in starlight. The atoms that make up a human hand were forged in places just like the ones glowing in Webb's images. Hydrogen, born from the Big Bang, found companionship with helium in the earliest stars. Those stars burned, lived brief and violent lives, and then died in spectacular explosions. In those moments, heavier elements were born: carbon, oxygen, iron, scattered into space like ashes from a cosmic fire. Over time, gravity gathered those ashes into new stars, new worlds, new beings. When Webb photographs a stellar nursery, it is not just documenting creation, it's watching a memory of us before we had form. The telescope doesn't simply show us what we're made of, it shows us how we came to be. The same forces that shaped galaxies shaped our cells. The same light that traveled through the birthplaces of stars now enters the pupils of our eyes. In that quiet exchange, light meeting awareness, the universe completes a circle. It becomes aware of itself. For the first time in billions of years of cosmic unfolding, the light that left its source returns not to dust or darkness, but to understanding. When Webb peers into a nebula, the image shimmers with colors translated from infrared, hues our eyes can't naturally see. Yet there's something deeply human in those colors, as though the universe has been waiting to be seen, waiting to be named. The act of observation is not passive, it's creative. Each glance pulls patterns from chaos, draws meaning from light. The images are more than data. They are dialogue, a conversation between matter and mind. What does it mean that we can look back so far, that our technology, built from metals mined from ancient rocks, can unfold in space and return visions of the universe's earliest days? It's as though the cosmos reached a point where it began constructing eyes for itself. Eyes that could see across time. Eyes that could ask questions. Webb is one of those eyes. Humanity is another. Through it, the universe explores its own depths, not out of curiosity alone, but out of something resembling longing. The instinct to understand what it is and how it came to be. There's a strange intimacy in this idea. Somewhere, on a small blue world orbiting an ordinary star, beings made of recycled stardust build a mirror, aim it toward the beginning of everything, and wait for the faintest light to arrive. That light, once it reaches us, completes a journey longer than all of human history. It began before Earth existed, before the sun ignited, before time even flowed as we know it. When we look at it, we are not just witnessing the past, we are participating in it. The observer and the observed merge into one seamless story. It's easy to forget that the telescope itself is an extension of us, of our curiosity, our desire to reach beyond what the eye can hold. Webb's mirrors were polished by human hands, its instruments tuned by human minds, its golden panels reflecting the same sunlight that once warmed ancient seas. Through it, we reach into the past not with arrogance, but with reverence, knowing that we are small yet capable of wonder vast enough to match the sky. The telescope is both a tool and a symbol, proof that consciousness can build a bridge across time. Sometimes, late at night, when the images arrive, clusters of galaxies bending light around invisible masses, stars forming behind veils of dust, astronomers describe feeling something beyond discovery, a quiet recognition. Because what they're seeing is not alien, it's ancestral. Those lights are family portraits. They show the universe in its youth, awkward and raw, yet already carrying within it the potential for life, for awareness, for memory. To see them is to glimpse the beginning of the story that eventually became us. Perhaps this is why the images strike so deeply. They awaken something wordless, a feeling that isn't about knowledge but belonging. In their stillness, we sense motion. Not the motion of galaxies, but of a narrative that connects everything. We realize that our existence is not an accident floating in a void, but an echo of a much larger rhythm. Every heartbeat, every thought, every act of love or fear or hope is a continuation of that rhythm. Webb's light doesn't just show the universe expanding, it shows consciousness unfolding alongside it. There's also a quiet irony here. The further we look, the older the light we see. To observe the earliest galaxies is to peer into a time before the atoms that form our eyes existed. Yet it's through those same eyes that the universe's first light is finally seen. The past reaches forward, the present reaches back, until the two touch across an unfathomable gulf. It's not just observation, it's reunion. In this light, the concept of self begins to blur. Where does the universe end and the observer begin? The boundary dissolves, revealing that we are not separate from what we study. The act of seeing is itself a form of participation. To witness the cosmos is to be the cosmos, momentarily aware of itself. The universe, through Webb and through us, folds in on its own story and whispers, "I see you." Such moments make you wonder whether consciousness is a natural outcome of complexity. Whether, given enough time, stardust inevitably begins to dream. The human mind, after all, is made of the same particles as the nebulae Webb photographs. We are the continuation of the same process, shaped by the same physics, driven by the same hunger to expand and connect. The mind is simply the universe turned inward, discovering meaning in its own reflection. When Webb captures the faint glow of a galaxy 13 billion years away, it's doing more than collecting photons. It's preserving the memory of creation, translating energy into understanding. In that exchange lies the essence of existence, that matter seeks to know itself, that light carries both information and intimacy. Each image is a reminder that awareness is not separate from the cosmos, but an expression of it, like a wave rising from the ocean's surface, distinct only for a moment before returning to the whole. Perhaps that's why the images feel sacred. They don't just tell us what's out there, they remind us what we are. Not observers standing apart, but participants woven from the same thread. Each glance into the telescope is a kind of awakening, the realization that the eye and the infinite are one, The photons Webb gathers do not end their journey in silence. They complete it in consciousness. They arrive home. So when you look at one of those images, the swirls of dust, the arches of light, the galaxies suspended in dark space, let it settle in slowly. You are not gazing into something distant or foreign. You are meeting your own origin, written in the language of stars. The telescope may be far from Earth, but what it reveals reaches closer than anything else ever could. It shows us that the universe does not exist out there. It exists through us, reflected in every question, every breath, every moment of wonder. And so as this journey draws near its end, one question lingers in the silence between those galaxies, between our thoughts. What are we truly seeing when we gaze at the ghosts of creation? Are we studying the birth of light, or remembering something our atoms have always known? That in every spark, every photon, every pulse of the cosmos, the universe has been looking back all along. Maybe the ghosts Webb reveals aren't out there at all. Maybe they have always lived within us, moving silently through the rhythm of our breath, carried in the pulse of our blood. The telescope, floating in the cold silence of space, sends back images of distant galaxies and collapsing stars. But what it really sends home is recognition. The light it captures, stretched and worn by time, reaches us not as strangers from another world, but as messengers from our own origin story. When we look at those faint glimmers in Webb's deep field, we're not peering into something alien. We're looking at the pieces of ourselves scattered across time. Every breath we take is a quiet communion with the cosmos. The carbon we exhale was once part of a star that burned long before Earth existed. The calcium in our bones was fused in the heart of a giant whose death painted the sky with elements. The iron that gives color to our blood was born in an explosion so violent that it tore through space like a scream frozen in light. Those atoms drifted for eons, folding into new clouds, into planets, into life. When you touch your own skin, you are feeling matter that once illuminated a galaxy. You are made of stars, not as a metaphor, but as a precise physical truth. Webb's images, for all their scientific precision, carry something that feels like poetry. The camera doesn't just show the distant past, it shows the continuity between that past and our present. Each speck of light in those photographs is a star system that may have lived and died before our sun was even born. Those distant suns forged the ingredients that now whisper inside our cells. Looking at them is like staring into an ancestral portrait, at one where your great-grandparents are not people, but stars. You can sense it even without understanding the physics, that deep pull of recognition, that feeling of home. The telescope captures photons that began their journey billions of years ago. They left their sources before our solar system had even formed, before Earth's oceans shimmered under sunlight for the first time. They traveled through expanding space, stretching thinner with every passing moment, until finally they met the golden mirrors of Webb and were seen. In that meeting, something profound happens. The light that once belonged to the beginning of everything becomes part of human perception. The universe sees itself, not through equations or theory, but through eyes that evolved from its own dust. There's a quiet humility in that realization. We spend so much time looking outward, searching for meaning in distant stars, that we forget those same stars built us. We are not guests in this universe. We are its expression. The galaxy's Webb photographs are not out there in the cold distance. They are within the story of every heartbeat, every thought, every fleeting spark of consciousness. To study them is not an act of separation, but of reunion. The telescope becomes a bridge between the infinite and the intimate, between cosmic birth and personal existence. When Webb reveals a galaxy from the dawn of time, what we see is not just light, it's memory. Light that has crossed unimaginable distances carries with it the record of everything it has touched. It remembers collisions, births, deaths, transformations. It remembers the slow weaving of the cosmic web, the gravity that pulled matter together, the moments when atoms first began to dream of becoming stars. That same light now enters our eyes, fuses with our neurons, and becomes thought. We do not just witness the universe's history. We internalize it. We remember it through awareness. Think about how delicate this connection is. The same particle that once brushed against the edge of a newborn galaxy now ends its journey in your mind as an image, a sense of awe, an emotion you can't quite name. It's as if the cosmos planted seeds of itself in every living being, waiting for the moment when those seeds would grow into curiosity. The human desire to understand, to look up and wonder, is not separate from the universe. It is the universe continuing its own creation, seeking to know itself through reflection. There's a tenderness in that idea. To be human is to carry both the vastness of the cosmos and the fragility of existence. We are built from the ashes of stars, yet we bruise, we age, we fear, we love. Somehow, out of the violence of stellar explosions came the softness of thought, the warmth of connection, the quiet awareness that asks questions in the dark. When Webb gazes into ancient light, it's not uncovering a mystery that was ever truly gone. It's tracing the lineage of meaning, from burning plasma to consciousness. In the grand timeline of the cosmos, our lives are less than a blink. Yet that blink contains the ability to see across eternity. We often think of the universe as indifferent, a cold expanse without purpose. But the fact that it has produced beings capable of perceiving beauty, capable of finding stories in starlight, hints at something deeper. Maybe purpose isn't something we add to the universe. Maybe purpose is what happens when the universe looks back at itself and feels wonder. When you look at Webb's images, the delicate spirals, the fiery nurseries, the quiet arcs of gravitational lensing, you are seeing not only what the cosmos was, but what it became. You are part of its continuation. Every cell in your body hums with the echo of nuclear fusion. Every thought arises from matter that once floated freely in space. The boundary between you and it is thinner than it appears. In some distant way, you are the universe remembering its own beginning. The ghosts Webb reveals are not specters of something lost. They are traces of what endures, the persistence of creation across billions of years. They remind us that nothing truly vanishes, that every particle carries the history of everything that came before. The light we see today is the same light that once touched the earliest atoms. The atoms in us are the same atoms that once burned in forgotten suns. The continuity is unbroken, only stretched by time, like the redshift of light as the universe expands. There's comfort in that continuity. It means that existence is not a fleeting accident, but a long, unfolding story, still being written through us. We are not separate chapters, but paragraphs within the same cosmic sentence. Webb's discoveries are not just about science or data. They are about belonging. They remind us that the universe isn't a distant stage upon which we appear and disappear, but a living field in which we bloom for a while, made of the same substance as the stars we admire. So perhaps the ghosts Webb reveals are not haunting us from the past. Perhaps they are guiding us, reminding us of what we are and where we come from. The faint smudges of distant galaxies are not cold remnants of what once was. They are reflections of what still is, what always will be. They whisper that creation never truly ends, it only changes form. The universe continues through every breath we take, through every beam of light that touches our skin, through every question that stirs in the human mind. When we gaze upon the early universe, we are not just seeing our past, we are witnessing our own becoming. Webb's mirror doesn't only reveal the cosmos, it reveals memory, identity, and the quiet persistence of existence. The ghosts of creation are not strangers drifting in the void, but the deepest parts of ourselves, shining back across time. And perhaps that is the most beautiful ghost of all, the one that never leaves, because it was never gone. It lives in every heartbeat, every spark of thought, every act of wonder that turns the universe into something aware of its own light.